Okay, welcome to section 5.3. Our objectives are I can apply properties of medians and altitudes of a triangle. So some more terminology of triangles. Stay with me, maybe take notes. So first of all, the median of a triangle is if you were to cut a side in half and then go to the opposite vertex, meaning the opposite angle. So if this was 6, you'd cut this in half, so it's 3 and 3, and then you would just go through the opposite angle. So if this side was maybe 4, you'd cut it in half, so you have 2 and 2, and then you'd go through this opposite angle. Same thing for this. If this was 8, you'd cut it in half, so you'd have 4 and 4, and you'd go through to the opposite angle. Now there is going to be a spot where they meet right there, and that is actually called the centroid of the triangle. Now the centroid of the triangle is actually the center of gravity. So if you were to have this triangle and put your pen in the center of that triangle, the triangle should be able to balance on that point because it is the center of gravity. Okay, so the centroid has to deal with the sides being cut in half, bisected sides going through the opposite angle. And what this centroid theorem tells me is that this whole line, this guy right here, is kind of cut into thirds. So this is a third of the line, and then you cut this cut in half, you have 1/3, 1/3, so this part is like 2/3. Okay, so if, for instance, if this was 3, this would be 6. Okay, because technically you'd have 3 plus 3, and then another 3. Same thing if you had 4 here. Actually, a different example. Let's say 4 here. Okay, so this is 2/3 of it, so you have a 4. So cutting that in half, you have 2, 2, making this 2. So the whole thing would be 6. If this whole thing was 12, and you were trying to find this part, that would be a third of it. So cutting that in thirds, you'd have 4 there. Making this part right here, what? It would make it 8. Okay, let's do another example. If this part was 1, what would this part be? It would be 2. What would the whole thing be? Well, it would be 3. Okay, so if you need to draw it out, let's say I said this was, let's say this was 5. Okay, so I'm going to draw the whole line right here. And I know that's the smaller part, the 1/3 part, and I know it's 5. And this part is 2/3, because that's what my theorem tells me. Okay, so what I can do is I can take this 1/3 and just times it by 2. This would be 10. Okay, let's say that this whole line was 20. The whole thing is 20. And I want to find, let's say, 1/3 of it. And actually, let's make it a little bit easier. Let's go 21. Well, I can divide this into 3 parts, so that would be 7, and this would be 14. Okay, so let's say this whole thing is 9. This part would be 3, and this would be 6. You're just cutting into thirds. Let's see what else. Let's do 18. Okay, so divide 18 by 3, you have 6, and 6 times 2 is 12. Okay, 12 plus 6 is still 18. There we go. Okay, so just learn to manipulate your thirds. That's what the centroid is going to be doing. Okay, key word here is the median, or if you see that you have the sides are cut in half and it's passing through the angle. So looking at this one, I see the sides are cut in half, it's passing through the angle, and I have RL, this whole thing, RL is 21. And SQ, this is 4. They want us to find LS. So since I'm looking at this line, I'm probably going to ignore the QS right now. So we want to find LS. Make a reference to that, LS. Okay, and if you need to draw this line like this to figure it out, you can. The whole thing is 21. Okay, LS looks like it's the longer part, so that's 2/3. And then RS is smaller, so that would be the 1/3 part. So if this whole thing is 21, how much would the 1/3 part be? Well, 21 divided by 3 is 7. If this is 7, how much would the 2/3 part be? It'd be 14, because 17, or 7 plus 2, or times 2, is 14. So 7 plus 14 is still 21. Okay, now looking at this line here and looking at this, LS was the bigger part, right? So this was LS. So LS appears to be 14. Okay, let's do another one. So this one, we have 21 again, SQ is 4, and we're trying to find NQ. Okay, so let me draw my little line here. So this is N. Oop, let's draw it a little bit better. NSQ, and SQ appears to be the 1/3 part because it's smaller, which means that this is the 2/3 part. We're trying to find NQ. Okay, and sometimes it just helps to draw this line right here. If you're able to do it without the line, by all means, go for it. Just helps me a little bit. So if this is 4, then this must be 8, because it's twice the length of that, which makes this whole thing 12. So NQ is 12, because that would be the entire thing, 12. Okay, let's look at this one. ZW is 7, let's label. LX, this whole thing, is 8.1, and we're trying to find KW. Okay, so KW, I don't need this, I just need that 7 there then. Okay, so we got KW, and Z appears to be here. W appears to be the smaller bit. Now if you're not 100% sure where the smaller bit is, look at the angle. The angle side is always going to be the longer side. So you got your 2/3 part here, 1/3 part. Okay, and by angle side I mean K is where it's hitting the angle, and this is the angle side. Just like this would be the angle side, see it's hitting the angle. This is the side, the side. So if this is 7, this would be 14. Now what we're trying to find, KW? Yes, KW. So KW would be 7 plus 14 is 21. Okay, this time we're trying to find LZ. And we have the LX. LX, the whole thing is 8.1. This is Z, okay, so XZ from the side to the center is the 1/3 part. LZ, the angle to the center, would be my 2/3 part. Okay, so easiest way to go about this is do 8.1 divided by 3, and I can do that in my calculator. Dividing by 3 of 2.7, that's going to be 1/3 of it. Oops. Okay, to find 2/3, I can times that by 2. And I have 5.4. Okay, now what was I trying to find? I was trying to find LZ, which I just got, 5.4. Perfect. So we're just dealing with thirds. Don't be intimidated by the fractions. You're just taking the big number divided by 3 or times it by 2 or whatever you may be doing. Okay, so find the average of the x coordinates here. So the average, remember you add them up and divide it by the number of things. So if you look at all your x coordinates in this, you have 0, 6, and 3. So you're going to add them up. Now how many terms are there? There are 3 terms, 1, 2, 3. Divide that by 3. And then they also want us to find the average of the y coordinates. So you have 8, 4, and 0. You add them up and divide it by the number of things that are there. Okay, so this would be 6 plus 3 is 9, divided by 3 is 3. And then 8 plus 4 is 12, divided by 3 is 4. So if I were to make a coordinate of this, 3, 4, and graph it, we have 3, 4, it looks something like that. which appears to be kind of in the center. This is actually the centroid. This is how you find your centroid. Okay, you find the average of the points and divide it by the 3. And this is your formula if you were to find the centroid. And you might want to write it down for reference. May or may not be on your test of knowing how to find the centroid. Okay, wow, that's a really bad arrow. I'm giving you time to write that down. There's my arrow. Beautiful. And a star. Yay. A bad star. Wow. There we go. Beautiful star. Okay. So this is the easiest way to find the centroid of a triangle. So all your x's added up, divided by 3. All your y's added up, divided by 3. And that's your new point. And you just plot your point, and that's your centroid. Your center of gravity. Okay, now let's talk about altitude. So altitude is usually the height of the triangle, where you go from the angle and you go perpendicularly through the opposite side. So notice on all the sides, so like this side, that line is perpendicular to that side and it passes through the angle. Okay, now you notice it kind of goes outside the triangle. That's okay. So if I were to make a line perpendicular to this side and try to pass through the angle, you notice I'm not hitting the opposite angle. So what I would have to do is I would have to imagine that this side kind of goes out and then go perpendicular to the side and go through the opposite angle. Okay, so if I were to draw a triangle like this, okay, so perpendicular to this side, going through the opposite angle would look like this. Okay, perpendicular to this side, passing through the angle. You notice that if I were to go perpendicular, nothing's really going through that opposite angle, which is this. So I would need to extend this side a little bit until I can go perpendicularly and through the opposite side. Like so. And that's a really bad perpendicular line. Wow. Okay, so just pay attention to how you're going about this. And you're usually just going to have these ones drawn out. I'm not going to have you usually graph it, or perhaps I will. We'll see. But this is called the orthocenter. It's where they all meet. Okay, the orthocenter. Think of your orthodontist. Orthocenter. Okay, so we're going perpendicular and through the opposite angle. And it's the height. We are graphing it. Okay, so find the orthocenter of this one. So first up, graph the triangle. Okay, and then we have to figure out where we're going perpendicularly and through the opposite angle. Obviously this one's going to be very easy, this side, because if you have a vertical line, the horizontal line would be perpendicular to that. So we have our perpendicular line is y equals 1. Now if you remember from Algebra 1, it's a y equals 1 line because it's passing through all the y equal 1s. All where y is 1. Okay, if you were to say x equals 1, that wouldn't make sense because x is all of these values. Okay, y is 1 all the time. So if x is 7, your y is 1. If x is 8, your y is 1. Your y is always 1. So that is the name of the line. Now you need to find the perpendicular line passing through an angle of another side. So this is where you need to remember your Algebra 1 stuff. Okay, so to get a perpendicular line, we're going to take the slope and we're going to find the opposite reciprocal, and that's going to be perpendicular. So the slope of xc is what they're starting with. So xc, they're looking at this right here. Okay, so to find the slope of that, if you recall, you're going to need this coordinate and this coordinate. So that x coordinate is 3, -2. And then your z coordinate is 7, 1. And if you don't remember this, you should write it down. Okay, and then to find your slope, you need your slope formula, which is your difference of your y's over your difference of your x's, rise over run. Okay, so I've got x1, y1, x2, y2. So we have 1 minus -2 becomes plus 7 minus 3. Okay, clean it up. We get 3 over 4. Okay, to find the perpendicular slope, we would flip it and negate it. Negate. Wow, that says the word negate, I promise. I can't write today. Negate, okay. So that's 4 over 3 is flipped and negated. Okay, so if it was already negative to begin with, it'd become positive. So you just do the opposite. It's the opposite reciprocal. So I know my slope. Very cool. Now, remember, your orthocenter needs to be perpendicular. This is perpendicular. And it needs to pass through this opposite angle. Okay, so we're talking about this side right here. And now what's the opposite angle to that? Well, it would be y. I need to pass through that angle. So we need to be perpendicular, which is this, and pass through that angle right there, that point. So that point is 3, 6. Okay, and if you remember from Algebra 1, anytime you're given a slope and a point, in order to find the name of the line, you're going to use point-slope form. Do you remember point-slope form? Probably not. So I will give it to you. So it's y1 minus y equals mx. 1 minus x. And let me just double check because it's been a while for me too. Oh, other way around. There we go. This is why we check. You guys will have it written down, I'm sure. There you go. Okay, so y minus y1 equals mx minus x1. So what you're looking at here is this is your point, this point right here, x1, y1. Okay, and m is your slope. So this is your point and your slope. You see your other x and y? You're not going to touch those. They're just going to stay as x and y. Okay, now let's plug in. So we've got our x1, y1. So you've got y minus 6 equals -4/3 x minus 3. Okay. Now this is the name of my line. They just wanted the name of my line right there. And I can clean it up if I want. That's what they did. We can do that if you want. Or if you're just graphing it, if you simply must just graph it, you can start at that point and you can go down 4. So start at this point, down 4. 1, 2, 3, 4. And then you could run 3. 1, 2, 3. Down 4. 1, 2, 3, 4. And then run 3. 1, 2, 3. Okay, so this is me graphing it. So it passes right there. And you notice it's not a very nice spot. So if they need that coordinate, that's not a very nice spot at all. Okay, so what I have now is I have the y equals 1 line. And I have this new equation as well, the other line equation. Okay, and if you're having trouble following along, you can rewatch this video if you need. You can check in your book for reference, and you can take notes, write these down. Okay, now I'm going to clean up this equation because this equation is kind of messy right now. So what I'm going to do first is I'm going to distribute this -4/3 in. And -4/3 times -3 is going to be, well, you can imagine this is over 1. You can have 12 divided by 3, which is 4 again. Positive 4. Okay, we're going to add 6 to both sides. Okay, so then my equation is y equals -4/3 x plus 10. And I'm going to go down here and check where we're at. Awesome, okay. Now in order to find out where they meet, you're going to have a system. And if you remember from Algebra 1 again, in order to solve a system, you need to actually set it up by doing substitution or elimination. For this particular case, I think it might be easier to do substitution. So if y equals 1, you can just take 1 and plug it in right there. Okay, and then you can just solve for x. And we get 6.75. Now you might be wondering, okay, if we're trying to find a point, that's only half the point. That's only 6.75, and then I don't know my y. How do I get my y? Well, you can take that and you can plug it back in right here and figure out what your y would be. Or you can just look at your line and say, okay, well, it's along this line where I said all my values are going to be 1, all my y values are 1. So no matter what I plug in, 6.75 or whatever, I'm going to get 1 as my y. Okay, and if you're not understanding that, you can take the 6.75 and just plug it in for x right there and find out what y you get. But you will get 1.